Okay, Monte Carlo simulations. Okay, so first of all, what does it mean Monte Carlo, right? What does it mean Monte Carlo? Okay, let's go through. So this Monte Carlo simulations is named after a casino center, okay, called Monte Carlo in 1975, if not mistaken. Okay, so when playing a game, right? When we play any game, there will be win or lose, right? This win or lose is not fixed, right? But it's random, right? Okay, so Monte Carlo basically is mean random simulations. Okay, so Monte Carlo is mean random simulations. So in order to be randomized, we need to generate the random numbers. So the algorithm we use to generate the random number, we call it as a random number generator. So later on, we're going to learn these random number generators. So for your assignment, you need to use these random number generators. Okay. So this random number generators is used to generate a series of random numbers. And the random number we use in this subject, this chapter, we call as a pseudo-random number. So what does it mean pseudo-random numbers, right? So basically it's a random numbers generated by the deterministic algorithm. So what does it mean deterministic algorithm? Right? Deterministic algorithm, what does it mean? Here one example, fx equal to x squared plus 1. Okay, so deterministic algorithm basically is a mathematical function. Okay, it's a mathematical function. So how to use this function to generate a series of random numbers, right? So in order to generate a random numbers, first we need a sig number. So later on your assignment will ask you to get a sig number. So what does it mean sig number here, right? Basically it's an initial value. So for example, x0 equal to 1. It's an initial value. Okay? So we need an initial value to generate the first random number. So plug into our functions. So we will get 2, right? Okay? And then from the first random number, we plug into it, we generate another random number, second random number. So 2 squared plus 1 equal to 5. And then from 5, we plug into the function, we generate another random numbers. Equal to 26. Okay? Okay. So this is a deterministic algorithm. We can't simply generate a series of random number. We need to generate a good series of random number. So let's go through these properties of good random number generator. Okay, so first properties is the random numbers must have a random pattern. So what does it mean random pattern, right? Let's take a few examples. Okay, let's say this is a series of random numbers. Okay, and then another series. And then one more series. Okay, Okay, let's look at the first one. Do you think it has any random pattern? Yes or no? No, right. Okay. The pattern here is fixed already, right? 5, 6, 7, 8, 9, right? So this does not have any random pattern. How about this one? 2, 3, 2, 3, fixed already, right? Okay. About last one. Yes, right. Okay. So this has a random pattern. When it has a random pattern, it means the output is unpredictable. You don't know what is the next number. Okay. Unless you know the algorithm. Okay. So you need to have the random pattern, the random number generator. And then second, need to have to be long period. So what does it mean period here, right? Okay, because we are using the deterministic algorithm, right? We are using this deterministic algorithm. So the random number will be repeated. Okay, will be repeated. For example, 153, 153, 153. Okay, this is one cycle. So one cycle we call it as a one period. Okay, but this is a very short period. Okay, the problem of short period is very easy to predict the outcome, right? You will know next cycle will be 153 again, 153. So we need to have very long period. For example, we can have the longer period, 153, 6, 2, 4. Okay, so another cycle will be 153, 6, 2, 4, and so on. So this is longer period. Okay, the best is you need to have very long period. For example, 1000. That only, okay. And then the third property is efficiency. So if someone say you are very efficient, what does it mean? Someone say you are very efficient. So efficient means very fast, right? Okay. So random number, okay, generator must be fast. Okay, random number generator must be fast so that the simulation will be faster. Okay, number 4 is the repeatability. So what does it mean repeatability, right? So repeatability is mean the same initial value. Okay, so the same initial values or due to same sequence of random numbers. Okay, so what does it mean, right? What does it mean? Okay, so for example here, just now I shown to you. For example, when the initial value equal to 1, so it always will generate the random number equal to 2. Okay, must be consistent. And last one, portability. So what does mean portability, right? This case mean portable. Okay. So the same sequence of random number on different platform. For example, iOS and Android. So both generate the same sequence of random number when we apply this generator. Okay. Okay, now let's go into the first random number generator. Okay, first random number generator. So first one is called linear congruential generator. LCG. So this LCG, I think Python is using this LCG to generate the random numbers. Okay, for the random number generations. Okay. So for every random number generator, there is one deterministic algorithm. Basically, it's a mathematical function. So the function for this linear congruential generator is this one, plus C. Okay, mod n. Okay, this A, C, and N, basically they are constants. Okay, they are constant. Okay, this modulus here, what does it mean, right? This modulus here, what does it mean? For example, okay, let's say this part equal to 8. Okay, for example, let's say this part equal to 8 mod n. Let's say m equal to 5. Okay, so this modulus here is mean we take the remainder. Yes, remainder. So 8 divided by 5, what's the remainder? Yes, 3. So which means we use the remainder as a random number. Okay, we use the remainder as a random number. Okay, so since the remainder is based on this m here, so the range of the random number generators will be from 0 to m minus 1. Okay, it will be from the range for the random number generator will be from 0 to n minus 1. For example, if we want to generate a random number from 0 to 10, what should be the m value? Anyone? Yes? Yes, 11. 11. One more than the last number. Okay, 11. Okay, let's go through this full period. Just now we have gone through this period, right? Period is mean one cycle. One cycle. Okay, so let's say you want to generate a random number from 0 to 5. Okay, from 0 to 5. So, for example, 1, 3, 5, 1, 3, 5, 1, 3, 5, 3, 5. So this is one period, right? Okay. Okay, and then another one for you. Okay, 0, 2, 1, 3, 4, 5, for example. 0, 2, 1, 3, 4, 5. 0, 2, 1, 3, 4, 5. Okay, so this is one period. right? One cycle. Okay. Okay, this 135 is not a full period. Okay, it's not a full period. Okay, this one is a full period. So what does mean full period, right? What does it mean? For full period is, yeah, every number will appear as a random number. You see, every number from 0 to 5, they appear as a random number, right? So this is full period. This 0 is missing, 2 also missing, 4 also missing. Okay, so we need to make sure that every number appears as a random number to ensure the fairness. Okay, so every number has chance to appear as a random number. So how to generate a full period random number, right? That's a condition. Condition for full period of to generate a full period of random numbers. So what is the conditions? A and C. So A and C refer to the constant here in this formula. A and C must be prime numbers. Okay. So what are the prime numbers? 1, 1. What are the prime numbers? 1. Okay. I think you all know, right? Okay, so the formula for LCG just now is this one, right? Plus C. Okay, so from this LCG, we can derive another two generators. Okay, we can derive another two generators. Okay, when A equal to 1, so when A equal to 1, this part equal to 1. So here will be Sn minus 1 plus C, right? Mod M. Okay, now this part, there's no more multiplication, right? There's no more multiplication here. Only addition. So when only addition, we call it as an additive LCG. LCG. Okay. So when question asks you to find, okay, to use our additive LCG, it means refer to this one. A equal to 1. Okay, then there's another possibility is C equal to 0. This C equal to 0, so the formula will be A times S power n minus 1 mod M. Okay, now this part, okay, this part, there's no more addition, right? No more addition here, only multiplication. So we call this as a multiplicative LCG. Okay, so you need to know three of them. Okay, so this one, there is a multiplication and addition, right? Multiplication and additions. So this one normally we call it as a mixed LCG. It's mean mixture of addition and multiplication, mixed LCG. Okay, there is a multiplication here and addition here. So called as a mixed LCG. Okay, so let's see how to use this LCG to generate a series of random numbers. Okay, so let's go through one example. So given m equal to 8, just as I mentioned, right, m, a, c, they are constant. Okay, so given the value for m, a, and c. and the initial value equal to 4. Okay, so let's generate a series of random numbers from here. So write down our formula. And fill out all the constants. A equal to 5. C equal to 7. M equal to 8. Okay. So let's start with the first random number, S1. So M equal to 1. First random number. So 1 minus 1 here with S0. So S0 initial value equal to 4. So equal to 27. 27 divided by 8. What is the remainder? 3, right? Okay. Now we want to generate second random number, S2. So equal to 5 times S1 plus 7 mod M. So S1 equal to 3. Okay. So 15 plus 7, 22. So 22 divided by 8, what is the remainder? Yes. Yeah. Yes. And the n equal to 3. That's 3. 5 times S2. 5 times S2. Right? Plus 7. So S2 equal to 6. Okay, so equal to 37. Okay, 37 divided by 8, what's the remainder? 5, yes. Okay. So quiz number 2. 5